Good evening. I am Sujit Menon, working as Director Operations for Greenworld. Our key speaker, who's also connected online, his name is Mr. Aloysius G. Pasion.
Thanks, Sujit, and thank you for the opportunity. So, what are the essential elements of food safety? I have come up with a couple of points which I feel are really essential to ensure food safety. First, brilliance at the PRP basics. Second one is have your HACCP at the shop floor. So, you have verified your HACCP, your PRPs are strongly in place. They have been verified that they are effective. They are really working for you in such a way that they're providing the foundation for your quality system. So now you can now develop your HACCP study, yeah, or your HACCP program. So just to quickly describe, so when we say HACCP, so we're talking about what is a hazard and what is the risk associated with that particular hazard. So when we say hazard, we're talking about a contaminant or an agent that can cause an adverse health effect to the consumer. Taking into consideration what is the risk of this particular hazard coming into your process. So we're talking about, when we say risk, we're talking about the probability of that particular hazard and how it can come into your process. Yeah, so risk, particularly, it's the function of the probability of that particular adverse health effect and the severity of that health effect in consequential to a food safety hazard. Okay, so HACCP, straightforward. So it's a preventive approach in order for us to assure food safety. So in HACCP, we have an assessment to process to identify these hazards and to be able to identify control measures and categorize these control measures in order to make sure that these control measures reduce these hazards to an acceptable level. Okay, so in order for us to have a strong food safety management system, you need to have strong GMPs and strong PRPs, followed by a effective HACCP system in order to us to ensure food safety. So a HACCP system, basically, we need to manage and assess the risk. Yeah. So it basically, we want to identify those hazards, what are the characteristics of those hazards, and we need to assess the exposure of the product to that particular hazard. And then once we have identified and analyzed these hazards, then we need to manage these hazards. So here we're talking about risk management, making sure that we are able to come up with control measures to address those hazards, and of course, to be able to communicate this risk. Yeah. So this risk, particularly your HACCP plan, where you have identified the particular hazard for that particular control measure. So this needs to be cascaded, wherein you educate your teams to make sure that they have an understanding of what are the risks that you have in your system and what is the proper way to manage this risk. Because if they are not in the loop, then you will have a tough time in really managing the risk of the hazard in the finished product before it goes to the consumer. So this is just an example of the comparisons on the implementation steps of HACCP with regards to what are the principles in Codex Alimentarius and as per the clauses that is defined in ISO 22001, 2018. So on the left side, you can see what are the implementation steps on how to correctly do a HACCP study and what are the relevant principles as per that is relevant for Codex and for ISO 22000. So in carrying out the steps for HACCP study, very, very straightforward. So you need to have your PRPs strongly in place. So you have a separate PRP plan to manage that. And then you set up your HACCP team and you define the scope. You define your the product that you would like to be covered in your HACCP study, and of course, taking into consideration the intended use of the product. You define now your flow diagram, conduct hazard analysis, identify your OPRPs and CCPs, establish the limits, establish a monitoring system, establish your corrective action, establish verification procedures, and validation of your control measures. So more or less, this is an effective way of developing HACCP study. So wherein these steps usually cover your preparation work for your HACCP study, and then you do a risk assessment and you manage the risk that is coming as an outcome of your risk assessment. Okay. So for preparations for a HACCP study, so basically here I just wanted to point out the composition and what is the responsibility of your HACCP team. And in managing the HACCP studies, what should be the content for your study? So most importantly here, worth to mention is that you define the scope of your HACCP study, and you have properly identified what is the study for, and describing also your HACCP team. So describing the product also in your HACCP study is very, very important. So these are just some of the information that you need to have in your HACCP study in order to really define now what is the product that is in scope. So here we're talking about characteristics of your end product. So description of your incoming materials, your food safety related specifications, taking into account your regulatory requirements for the country that you're manufacturing in, and also for the country that you're going to sell your product. Yeah. So your processing conditions is also important, that you need to describe it in your HACCP study. So the claims and label information, including instructions, how you distribute and how you deliver and how you store, how the consumer will use your product, and of course the possible unintended use or misuse, and of course what is the acceptable level in your end product that is related to food safety. Yeah, so in a nutshell, this is you need to properly describe your product, and this is some of the information that needs to be in place. So your process flow diagram, basically, this is a graphic representation of the sequence on how you manufacture your product. So something worth to mention is that the steps in your operations from the time that you have your materials received until these materials are used in the processing, in the process environment, taking into consideration also the input of other processing aids such as steam, water, compressed air, lubricants, your packaging materials, rework that you are using. So where is the waste and rework generation, the control measures that you have currently in your processes, what are potential areas that might be sources of allergen or microbial contamination. Yeah, so these are just some of the information that needs to be in place for your process flow diagram. I just wanted to emphasize that your process flow diagram is really important to make sure that you do not miss any critical step, because if you miss a step, you miss a hazard. The hazard analysis is conducted based on your flow diagram. So if you miss a step in your process flow diagram, that you miss to identify that particular process step, then you most probably will miss a hazard analysis based on that particular process step. And eventually, you might miss a control measure for that particular hazard. We strongly recommend an on-site verification in the shop floor by your multidisciplinary team when you do the on-site flow diagram. This is very, very essential. This is to make sure that you do not miss any particular step in your hazard analysis. So hazard analysis is the most important step when you conduct a HACCP study, because this is where you provide identification of potential hazards and where is the source or where it can be originated. So you also assess and define what are the hazards, specifically those that is significant for you to control based on the severity and the likelihood of these hazards. You identify those control measures that is relevant for that particular hazards and identify the prerequisite programs for non-significant hazards. And you categorize these control measures. Yeah. So these control measures you categorize through a decision tree. So depending on the type of certification that you have, if you have ISO 22000 or if you have Codex Alimentarius, so you define now whether these control measures are OPRPs, even control points, or even critical control points. What is important is that these control measures for significant hazards, it needs to be part of your product release. So it has to be part of your release system. So if you don't have it as part of your release system, then the likelihood in case that you have a deviation is that you will have a food safety hazard in your product. Okay, so in hazard identification, so it's quite straightforward. We identify now what is the potential hazard that needs to be described. So this particular hazard that we need to identify, it can either be biological, chemical, physical. It can be an allergenic hazard. It can be a nutritional hazard. I will not try to discuss this in detail because it's quite a mouthful. But I think this is very straightforward. One thing that I would like to emphasize, and this I have observed in a lot of HACCP studies that I have audited. There are a lot of HACCP studies wherein when they do hazard analysis, they just put under the hazard description that it's a biological hazard or it's a chemical hazard, it's a foreign body. We need to be specific on which type of hazard that is really significant for that particular process step. This is very important. Like for example, when we talk about a biological hazard, let's say for salmonella. Yeah, here we are very specific because salmonella is a facultative microorganism. So the control measure for that particular microorganism differs. Let's say if you're talking about yeast and molds, which is a spoilage bacteria. So the control measure for that is different. Or if we're talking about B series, that is already more than 100,000 CFU, which is already generating a toxin. So your hazard there is not the B series microorganism, but it's already the toxin that has been generated. Wherein once it is generated, you cannot identify or you cannot now define a control measure to remove the toxin. So this is very important that in hazard identification, you are specific on which type of hazard is really of concern for you at that particular process step. Next step, hazard assessment. So here we evaluate now or assess the hazards as per what is the origin or source of the hazard, what is the nature of the hazard, and what is the severity of adverse health effect. So severity of adverse health effect, it can be an acute condition or it can be an chronic condition. So severity of health effect here, we're talking about in an acute condition. So those that is severe and rapid, meaning it can come in a short span of time and then it starts suddenly. So chronic conditions, so we're talking about gradual effect of the hazard, wherein it can persist for a long time and can eventually lead to illness if you are exposed to that particular contaminant in a longer period. Yeah, so just some terminology on what we define for severity of health effect. So in categorization of the severity of health effect for your hazards, so this is just an example of how we categorize hazards depending on the severity. So of course, when you talk about choking hazards, we're talking about that, of course, it can cause fatality. So it can cause serious illness, or we're talking about foreign bodies that is hard and sharp. So it can also be a contaminant, let's say like aflatoxin, can be salmonella or E. coli, and can cause illness. So it can be some heavy metals or soft foreign bodies that can come into your processes. So this is just an example of how to categorize the hazards. So in hazard assessment, we take into consideration what is the severity of health effect of that particular hazard at that process step, and the likelihood of occurrence of when or the likelihood of how this hazard can come into that particular process step. So in likelihood of occurrence, we talk about the rough estimation of the frequency of the hazard that could possibly be present. So it can be a qualitative or a quantitative estimation. In our experience, what we do is for likelihood of occurrence is we take into account our detections that we have in our monitoring plan. We take into consideration our measures that we have in our quality pyramid. So we're talking about near misses, we're talking about consumer complaints, first time right failures. So this is some of the data that we take into consideration to determine the likelihood of occurrence. And we look at the probability of that particular hazard and what is the likelihood of it to cause harm. So when we take into consideration the likelihood to cause harm, so we're talking about particularly for chemical contaminants that can pose a chronic health risk to the consumer. Yeah. So once you have defined your severity and your likelihood, then you're able to categorize what are those hazards that is significant and what are those hazards that is not significant. Those significant hazards are those steps that you need to determine the control measures and eventually categorize these control measures either as an OPRP or as a critical control point. These are just some examples of a hazard assessment table that that you can benchmark on, just in case that still not in place for your food safety management system. So control measures, basically, when we talk about control measures, we're talking about high-level description of an action or an activity that is performed to produce and make the product safe. So when we say control measures, we're talking about the activity itself. I have seen a lot of HACCP studies that were in, they put that their control measure is the metal detector. Yeah, but that is not the control measure. The metal detector is an equipment. Your control measure is that your metal detector is validated, is effective, and is able to detect the probability of detection value that you have validated it on, and you are sure that it's working perfectly to detect that particular POD value. Okay, so you need to describe the action and activity. And when you describe, so we're talking about proper control measures that are in place. Like for example, when you talk about heat treatment is not the control measure. The control measure is particularly pasteurization to a certain temperature with a diversion system that in case that it does not comply with your temperature, then the product is automatically diverted. This is clearly emphasized when you validate your control measures. Yeah. So describe the action or activity when you define a control measure for your particular hazard at that particular step. So in categorizing control measures, so there are different decision trees depending on which type of certification you're aiming for. Like for example, the one on the left, so this is the Codex one. This is also on another manner or another decision tree. I just apologize. I cannot share the Nestle decision way of for the deciding categorization of control measures. But in principle, it's almost the same. Yeah, we just go for a certain length of determining whether this particular control measure is an OPRP or a critical control point. Because when we try to determine what is the categorization of that particular control measure, we need to define really if it is an OPRP or a critical control point, which I will describe later. So once you have described already your control measure and categorize it already, then you develop now your HACCP plan. Your HACCP plan tells you how you will monitor that particular control measure. Yeah. So identifying how you're going to do it, what's your frequency, who is responsible, what is your action criteria, your records, and very importantly, what is your correction in case of deviation. So here, when we talk about correction, we're talking about an action to eliminate the nonconformity, which includes the handling of the potentially unsafe product. Accordingly, once you're able to secure a product, you need now to determine what is the root cause of that particular nonconformity so that you prevent this particular issue from reoccurring in the future. Yeah. To complement your HACCP plan, you need to have a verification plan, almost of the same criteria, but usually on a much lesser frequency. And for verification plans, we look at records of that particular control measure and how it performed before. So control measures definition. So this one, we're just trying to differentiate what is a critical control point and what is an OPRP. Critical control point, basically, this is a control measure that prevents or eliminates a food safety hazard to an acceptable level. So we're talking about a food safety limit that is achieved by that particular control measure. An OPRP is a control measure, but it does not ensure that you will be able to achieve the hazard and control the hazard in an acceptable level. It controls the likelihood of introducing those food safety hazards in order for you to control the proliferation or the contamination of the food safety hazard, but not essentially reducing it to an acceptable level. So in an OPRP, you're unable to define a critical limit, but in a critical control point, you're able to define a critical limit. That is the main difference. Most HACCP plans or HACCP studies, they define metal detectors, X-rays as a critical control point. There's nothing wrong about that, but when you look at the definition for having a control measure that is really able to bring it to an acceptable level for food safety, so a foreign body detection equipment is not able to achieve this. Why? Because the performance of this foreign body detection equipment, you're verifying their performance based on a spherical test piece. And in real life scenario or in real instances, you cannot determine what is the orientation or what is the sizes of your contaminant when it comes into your process. Just to be straightforward, there is no such thing that any facility is foreign body free. If it exists, then we should have known about it, because it's really, we don't have the technology right now to have a foreign body detection equipment that guarantee food safety. Yeah. So the most that we can do is control the likelihood and to be able to make sure that our PRPs, our OPRPs and CCPs work hand in hand to make sure that we are able to manage these hazards from coming into our product. This is just an illustration of how the PRPs and OPRPs and CCPs work together. So if you have a critical control point, so here it's an absolute control measure. So you reduce the hazard to a below the critical limit. But if you don't have a CCP, or you have only OPRPs, which are your foreign body detection equipments, so it has to be working hand in hand, not to achieve a particular critical limit, but in order for you to exercise due diligence, yeah, to reduce the hazard as much as you can, that you do your system does as their obligation as a food manufacturer to exercise due diligence for food safety. So just some definitions for differentiating validation from monitoring and verification. So there, across the experience that we have with different companies, some companies or some food safety professionals, they have this what do you call this? They're not clear of the definition. Sometimes they have the definition for validation, but in reality, it's verification. Okay, so just to be straightforward, when we talk about validation, so we're obtaining evidence that the control measure, that if it is properly implemented, it is capable of controlling the specific hazard to a specified outcome. So we're talking about capability when we talk about validation. How are we able to prove that that particular control measure is capable? This is the main essence of validation. Monitoring, I think it's straightforward. So it's planned sequence of observations to see if your control measure is under control as what you have intended it to be. Verification, so it's application of methods in addition to monitoring to determine whether your control measure is still working as it is intended. So just to show an interrelation, so validation, you do it before you use your control measure, you need to validate your control measure. So you do it before you use it in order to make sure that your control measure is capable in the future of achieving the intended result. Monitoring, you do it in the present time to see that your control measure is working as per your intention. So verification, you check your past experiences, your past records for your control measure to see how it is performing and to be able to assess if there is a possibility that it can have a deviation in the future. Okay, so validation, you do it before. Monitoring, you do it during. Verification, you do it after. So when do we validate? So again, this is also a hot topic for validation of control measures. In my experience, there is a lot of companies that is really that can really do much improvement on this particular aspect. And this is one mindset that we really would like to correct. So when to validate? So you do, as I said earlier, you do validation before you even implement your particular control measure, but you can do revalidation. Yeah, so meaning your equipment is already there, but if you have a change in your control measure, let's say you have a change in the probability of detection for your particular X-ray that you want it from, let's say it's be able to detect 2 mm SS316, that you want it to detect an even lower dimensions. So you can do a revalidation for that. You can also do revalidation if there's a new technology that you would like to test, or if you have a change in your equipment, if you have a change in your product recipe. So you will have also to revalidate your control measure. If you have a new hazard that has emerged, or there is a change in the occurrence for this particular hazard, let's say your hazards has increased from, let's say you have it before every 6 months, but now you're having it every month. So you're having an issue with that. So you can revalidate your control measure that is really capable of of the intention that you want for that particular process or equipment. And of course, if you have a new scientific information or regulatory requirement that you need to implement. So these are just some of the scenarios wherein you can revalidate. Yeah. And of course, when you have a failure in your system. So when you have a failure in your system, you need to revalidate your control measure just to make sure that it is still capable of the intention for your process.
So with that, we'd like to conclude the session. Thank you so much once again for joining us. Thank you, Mr. Aloysius. It's always a pleasure to have you on board. We are definitely looking forward to seeing you on one of our future events as well.